workshop on transition to IPv6. So I am Chaganti Srinivas, Deputy Director General DDG ICT from NTIPRIT, Department of Telecommunications. So I am going to be the host for today's workshop, and my colleague Mr. Sandeep Bharadwaj, who is working as a Director ICT in NTIPRIT. So he is going to be the co-host for today's workshop. My dear participants, the workshop was planned earlier, but could not be held due to certain engagements. Firstly, I would like to welcome our DG NTIPRIT, Shri Raju Sinha sir. Although sir has joined as DG NTIPRIT only recently, he has been extremely supportive and has helped us immensely in organizing this workshop. Welcome to you, sir.
Thank you.
Next, I would like to welcome Mr. Rajesh Charia. He is the president of ISPAI and all other say members of ISPAI who have joined today. I also welcome all the TSPs, participants from BSNL, MTNL, DOT headquarters, TRAI, Telecommunication Engineering Center, TEC, TRAI, then telecom industry bodies. So I welcome all the participants from these organizations. I also heartily welcome our eminent speakers of today. So we have 4 eminent speakers. We have Mr. Deen Dayal Toshniwal, my friend, who is working as a Deputy Director General New Technologies in DOT headquarters. So then we have Mr. Praveen Mishra, he is from EarNet, and we have Mr. Anand Raje from Basis Tech. It is an ISP, and then we have Mr. B. Nagaraj, who is my dear friend. He is working in Reliance Jio. So we have this for today's session. I welcome all the officers from NTIPRIT who have joined today's workshop. And last but not the least, I welcome all other participants who have joined in today's workshop. So I can see, dear participants, there are 2 types of internet protocols, version 4 and version 6. So version 6 is the latest one. All of you know that. And the current version of IPv4, which is the old version, it is more than 3 decades old, and it has got its own limitations. The biggest limitation is its 32-bit addressing space, resulting in 4.3 billion IP addresses. At one point of time, 4.3 billion IP addresses used to be a huge number, but not today. So the solution to this problem is making use of IPv6, which can accommodate increased demand by providing much large address space along with improved traffic routing. It also improves addressing capabilities of IPv6 by using a 128 bits address instead of 32-bit, thereby practically making available an almost infinite pool of IP addresses. Dear participants, IPv6 will play a big role in 5G, primarily because of IoT, which will add billions of new devices to this mobile network as its rollout. IPv4 cannot cope with the unique number of IP addresses that will be required, but IPv6 can. Dear participants, the focused efforts of DOT have led to the timely adoption of IPv6 and provided the potential for innovative application in different sectors. The IPv6 journey in India began with the release of National IPv6 Deployment Roadmap in July 2010. that is more than a decade ago. And DOT has also come out with a second version of it 3 years later. So as a result of the concerted efforts of DOT and all stakeholders, majority of the service providers in India have become ready to handle IPv6 traffic and offer IPv6 services. Dear participants, India has achieved around 75% IPv6 capability as against the world average of about 28%. And India also leads over developed countries such as USA, China, Japan, and United Kingdom on this front. In India, we have made rapid strides in transition to IPv6, but we could have done much more. Looking at the long journey of more than a decade when IPv6 deployment roadmap was first launched in July 2010. All of us know telecom equipment, the average lifespan is maybe around a decade or so. So this decade of the past decade could have provided enough time for us to migrate to IPv6. Of course, there have been a lot of issues. So looking into the importance of transition to IPv6 in a time-bound manner, Secretary Telecom has asked NTIPRIT to organize a workshop inviting all the stakeholders like TSPs, ISPs, etc. to know the difficulties and challenges faced by them in migration to IPv6 so that if any facilitation is required from DOT, it can be looked into. So now I will read out the, I'll just go through the program, session program in slightly detail. Siddharth, can you show the program of today? Yeah, thank you. So we have, my dear participants, we have divided the program into three sessions mainly. The first one is the inaugural session. So we are into this inaugural session. The second session is the technical session. So we have, again, in technical, we have four different sessions. The first session in technical session is on roadmap to IPv6. So it will be taken by none other than Shri Deen Dayal Toshniwal, who is working as Deputy Director General New Technologies in DOT headquarters. So he will be telling what all has been, say, done by DOT and what all has happened in the country over the past decade or so. And the second session, technical session, the second technical session of today is on IPv6 awareness. So this will be taken by Mr. Praveen Mishra. He is working as Scientist E at Arnet India in MIT. And the third technical session, it is on IPv6 deployment issues and challenges. So this is a very important topic, the issues and challenges. This is what we are all interested in. So this will be taken by Shri Anand Raje. He is from Basis Tech, an ISP. And the last technical session of today will be taken by my friend Shri B. Nagaraj, who is working as Executive Vice President in Reliance Jio Limited, Mumbai. So he will be taking on IPv6 implementation industry perspective. All of us know Reliance Jio has clearly made a headway in IPv6 implementation. So it is a lesson for all of us to learn what Jio has done. And my dear participants, the last session, that is the third session of today, we have scheduled for about 15 minutes or so. So this will be a discussion, and I request all the speakers, eminent speakers, all the four eminent speakers of today to be there till the end and to also participate in the discussion at the end of all these four topics to have a meaningful discussion. My dear participants, I hope that this workshop will provide a great opportunity to TSPs and ISPs and all other stakeholders in understanding and overcoming various issues and challenges faced by them towards faster adoption of IPv6 in the country by interaction with experts from industry and those from TSPs, ISPs who are leading in adoption of IPv6. This workshop will also help officers from DOT who are there in the who are there in the workshop today, and all other stakeholders for better understanding of the issues and challenges for enabling them for faster adoption of IPv6 in the country. My dear participants, as DG sir has just informed a while ago, our honorable member services could not join due to certain important engagement. This parliament has started due to certain important parliamentary work. He could not join. So I apologize for that. And so I now invite DG NTIPRIT, Raju Sinha sir, to give his inaugural address and also to declare the webinar open. Sir, just before that, a small brief about Raju Sinha sir. Although sir is quite known to most of us, but still, for the benefit of everybody, I'll just give his brief biodata. Raju Sinha sir is a senior ITS officer of 1985 batch and presently posted as DG, Director General of NTIPRIT, DOT, Government of India. He has worked in various capacities in both the state-owned telecom PSUs, that is MTNL and BSNL. He has very vast experience of planning of metro district network installation and maintenance. He has also planned state-of-the-art FTTH network and Wi-Fi for honorable members of parliament in Delhi. He has also worked for Smart City project in association with NDMC, which is NDMC, New Delhi Municipal Corporation. So over to you, sir.
Thank you, Chaganti ji. Good morning to all the participants, team NTIPRIT, learned speaker in the session, officers from DOT, Acharya ji, President ISPI, colleagues and friends. At the outset, I would like to congratulate team NTIPRIT and officers from NT wing of DOT for organizing this online workshop on very important topic, transition to IPv6 in India. So friends, technological innovations forms the foundation of the country's progress. You know, the rapid pace of technological development enables service access to all parts of the country, connecting the rural and remote part of the mainstream economy. Services, many services such as telemedicine, e-education, etc., are being made possible today with the help of technology. For that, backbone is also required to be ready. Various Government of India policy and its program provides infrastructure which enables the reach of services. With increasing penetration of broadband and growth of computers and mobile, there will be a requirement for more and more internet protocol addresses for the client and the host to communicate amongst themselves. Innovation of IPv6 enables accommodation of increased demand by providing much large address space, almost infinite, along with the improved traffic routing, which uses 128-bit. So 2 to the power 128 is almost infinite. The IPv6 journey in the India began with the release of National IPv6 Development Roadmap in July 2010. I remember my days when this policy was announced and meetings started taking place at DOT level, chaired by member technology at various stages. The network which were already deployed were latest with the IPv4 protocol at that time, and which proved to be good enough to serve the services to the citizen of nation. But with the foresightedness of deployment of IPv6, the lot many changes were required in the network. So the core network that includes routers, switches, etc., were in the hand of OEMs with a and was requiring a good expenditure to be made to enable it to IPv6. Though it was a little costly to since capital investment had already been done, but with greater study, it was possible to come over the enabling IPv6 in the core part of the network. Still, the problem was lying with the CPs already deployed in the network across the district and across nation. So extensive sensitization of various stakeholders, including the government, state government, PSU, TSPs, ISP, equipment manufacturer, academic institutions, and other stakeholders was undertaken, which led to many of them becoming IPv6 ready. An enormous meeting took place at DOT level, and it dragged it well. To consolidate the gain and build further from the achievement of the first roadmap, the second version of National IPv6 Deployment Roadmap was released in March 2013. Many classical methods were there, which were getting adopted by service provider like dual stacking, tunneling, header translation, etc., to transit from the deployed IPv4 network to IPv6 network and keeping the services intact without any interruption. The participants, with a vision to take global leadership position in the technological field, India has achieved around 75%. India has achieved around 75% IPv6 capability as against the world average of 28.18%. And it leads ahead of the many developed countries like USA, China, Japan, UK, etc. Globally, India is maintaining the leading position since last 2 years in this endeavor. As per the report of APNIC, as you know, which distributes and manages internet number resources in the Asia Pacific region, the percentage of IPv6 users has grown from 3.22 in January to almost 24% in January 2020. India's CAGR growth for IPv6 users is at 413%, which is phenomenal as compared to other developed countries like USA and others. Also, the total number of users has grown at a 25% CAGR. I was just seeing the instruction issued by DOT in November 21, which directs that all new retail wireline connections provided by DSP after 31st December 22 shall be capable of carrying IPv6 traffic either in dual stack or on native IPv6. The instruction also directs that the service provider will progressively replace or upgrade CPEs which are not IPv6 ready and are owned by service provider, and it should be completed by December 22. So that is the important task to be done by all stakeholders. You also know that 5G is around the corner. Bidding has started yesterday. So IPv6 is to play a big role in 5G deployment and service to be extended. You all know this is primarily because of the IoT, which will add many new devices, large number of new devices to the mobile network and its rollout. It is just not possible without deployment of IPv6. So in this workshop, with very thoughtful topics on roadmap to be explained by Toshniwal-ji, awareness part, issues and challenges, and industry perspective, I'm sure that this workshop will provide a great opportunity to ISPs and other stakeholders in understanding and overcoming impediments towards the faster adoption of IPv6 in our country. They will have an opportunity to interact with learned speakers that NTIPRIT has arranged, and experts from the industries and those TSP, ISP who are leading in the adoption of IPv6 and have joined as participants in this workshop. This workshop will also help NTWing, NTIPRIT, and other stakeholders for better understanding for enabling them for faster adoption of IPv6 in the country. So finally, I appreciate the efforts put by the ICT faculty of NTIPRIT led by Sri Chaganti DDG in association with NTWing of DOT in conducting today's workshop. My best wishes to all the participants and organizers of this workshop. Now I declare this workshop open. Over to Chaganti.
Thank you, sir. Thank you so much for your kind words and your thoughts about this workshop. So indeed, we are very grateful to you, sir. You have opened the workshop. So I am really thankful to you. I am also thankful to Rajesh Charia ji, President ISPI, for I mean, it is basically his workshop. Basically, he's the president of ISPI. So all this, ISPs and number of TSPs are there. So I'm very, very grateful to Rajesh Charia ji. I am also thankful to my friend in DOT headquarters, Mr. Toshniwal, for all the support that he had given. I'm also thankful to all the participants who have joined in overwhelming numbers. The figure has crossed 308. So, I mean, this overwhelming response, as I said in the beginning, it encourages us at NTIPRIT to come out with more such programs in the future. So now we come to an end of the inaugural session. So the next session is the technical session. So I request my co-host Sandeep Bhardwaj ji to take over from me for the technical session, please. Mr. Sandeep.
Thank you, sir. A very good morning to everyone joining this workshop. I am Sandeep Bhardwaj, Director ICT at NTIPRIT. On behalf of NTIPRIT and the DOT, I extend a very warm welcome to all the participants, our eminent speakers in this workshop, and the distinguished guests gracing the occasion. Sir, we are now moving to technical sessions of the workshop. As already told, there will be 4 technical sessions. First session will be of around 50 minutes, followed by 3 sessions of 30 minutes each. The last session will be for discussions and question and answers. Sir, as already mentioned by Srinivas sir, the first session will be taken by Sri Deendayal Toshniwal, DDG, on roadmap to IPv6 implementation. And the next session will be on IPv6 awareness by Sri Praveen Mishra, Additional Director and Scientist E at ARNet India MIT. Then we will have 2 more sessions, IPv deployment issues and challenges by Sri Anand Raje, Basis Tech, and the 4th session will be on IPv implementation industry perspective by Sri V. Nagaraj, Executive VP Reliance Jio. This workshop will be concluded with the discussion session in which participants can ask questions by raising their hand or writing in chat box, and one by one their question will be taken in that session. Let us DDG NT-DOT. Before I request sir to take over, let me introduce him to the audience. Sri Dindayal Toshniwal is an ITS officer of 1990 batch. Apart from BE in Electronics and Telecom Engineering and MBA in Marketing, he has done postgraduate diploma in Public Policy and Management from MDI Gurgaon. He is having more than 30-year extensive experience in various telecom domains, including wireline and wireline networks. Presently, he is posted as DDG Networks and Technology at DOT headquarters. Over to you, sir.
Thank you, Sandeep. Thank you, Chaganti sir. And thanks to all the organizers for giving me this opportunity to present the roadmap of DOT with respect to transition to IPv6. So is the slide visible to everyone?
Yes, yes.
OK, thank you, sir.
Yes, sir.
So, dear participants, I am myself overwhelmed by the participation in this particular workshop, which has exceeded 300. I have attended many workshops and webinars, and never have I seen such a huge participation. So thanks to the organizers for spreading the word, and it also emphasizes that IPv6 transition is such an important topic that people from so many departments, from DOT, from TEC, from field units of DOT, and then members of the industry, they have all logged in today to be aware of the developments going into this field. I am very happy to note that India is leading the IPv6 transition, and it is leading by far compared to even the advanced countries. But our lead is mainly due to the four wireless telecom operators, Idea and Vodafone. They are counted separately. So the lead is due to all the LT customers of Jio being on IPv6, and then Vodafone, Idea, as well as Bharti Airtel. Apart from these four, the progress is not good, and that is understandable because of the legacy network. So as already discussed during the inaugural session, why there was a need for transition to IPv6 from IPv4. So IPv6 allows more unique TCP/IP addresses, 4.3 billion in IPv4 to around 340 trillion. So seemingly infinite number of IP addresses in IPv6. Why this was required? Because with IoT, Internet of Things, the number of devices which need an address to communicate with each other became increasingly increased manifold. So our thanks to IETF, which as far as back as 25 years ago, decided to go for IPv6 addressing. But the world has not been able to make a very fast or rapid progress in the IPv6 transition. And this is mainly due to three factors. One is the complexity, another is the cost, and then the time it takes to make the network IPv6 ready. So it is the IPv6 or IP protocol, Internet Protocol, IP addressing, whatever you call it, it is the core part of how the Internet operates. And if we take the example of India, there are around 1.15 billion mobile internet users in the country, as per the TRICE report of May 22. And if we assume around 5 unique IP address for every citizen, then also we will need more than 5 billion IPv6 IP address in the country alone, whereas IPv4 could provide only 4.3 billion IP addresses. So India also needs to migrate to IPv6 so that we are able to communicate properly. So what are the advantages of IPv6 and why IPv6? IPv6 is first and foremost requirement is security. Now, currently we are using NAT. So network address translation, because of this, our networks are less secure. And then IPv6 provides end-to-end encryption, which is not possible in IPv4 because of paucity of addresses. So India rightly recognized the need to make a transition to IPv6 and came out with a policy in 2010 and then again in 2013. The National Telecom Policy 2012 also aimed to achieve substantial transition to new IPv6 protocol in the country by 2020. And in NDCP 2018 also, IPv6 transition finds a mention. It says that ensuring the transition to IPv6 for all existing communication systems, equipment, networks, and devices. India is the only country in the world with 2 IPv6 ready logo approved labs to ensure network infrastructure is IPv6 ready certified, which is the first significant step towards the IPv6 transition. So as I mentioned earlier and as it was mentioned during the inaugural session, DOT came out with the first roadmap in July 2010 and subsequently again it came out with a roadmap in March 2013. The first roadmap provided step-by-step guidance and suggested action plan for transition of various stakeholders such as government organizations, service providers, equipment manufacturers, etc. to IPv6. It also highlighted the various international best practices which were being adopted globally and the IPv6 standards and certifications. And it goes to the credit of DOT that all the stakeholders were extensively sensitized through various workshops, resulting in significant progress in IPv6 transition. And I'm happy to share that this NT unit, Networks and Technologies unit, was originally created to cater to the requirement of IPv6 transition in the country, and NT units were created in all the LSAs. The second roadmap, which was released in March 2013, defined the sector-wise timelines for IPv6 transition. It also highlighted the challenges and transition methodologies to be adopted by stakeholders, and significant progress has already been made in IPv6 transition across various stakeholders in the country, but still there are segments where the transition is taking longer time. And as I mentioned earlier, it is due to the legacy networks and complex nature of various issues. One of them is obviously the cost aspect. So accordingly, transition timelines have been reviewed and revised, first in 2016 and thereafter in 2020, and the last one was in November 2021. So despite the COVID-induced difficulties, India has made significant progress in IPv6 transition, but taking into account the COVID-19 pandemic, DOT revised the timelines for IPv6 migration and mandated that all government organizations should complete IPv6 transition and migration of their websites on IPv6 latest by 30th June 22. We are well past this timeline, and we are consistently engaging with the different stakeholders, government bodies. We have engaged also with NIC. We are taking up the issues with MIT, and to ensure that at least all the government websites are IPv6 compatible. So in this revised timelines, we had mentioned that all new retail wireline customer connections provided by all the service providers after 31st December 22 should be capable of carrying IPv6 traffic either on dual stack or on native IPv6. And service providers were requested to progressively replace, upgrade the CPEs. Now here we have left it to the endeavors of the service providers to replace the CPEs because it involves cost. So since this cannot be subsidized by the government, so it is up to the service providers to weigh the pros and cons of continuing with IPv4, because IPv4 addresses are also costly, around $20 per IPv4 address, whereas IPv6 addresses are virtually free of cost. So it is up to the service providers to weigh the pros and cons and replace the CPEs which are not IPv6 ready, and by 31st December 22. So against the world average of around 28 to 34% IPv6 transition, India is already leading the race with around 77% IPv6 capability. So core infrastructure of NICNet is fully IPv6 compliant for past several years. NICNet infrastructure at various ministries and state centers are IPv6 ready and supports IPv6 traffic up to the district centers. IPv6 allocation for national data centers, state data centers, states, ministries, etc. have already been done. And NIC provides DNS service for its IPv6 users with seconds, sir. So public IPv6 allocation for national data centers, state data centers, ministries have already been done. NIC conducts IPv6 training regularly for its resources for the latest updates. And on part of DOT, we have also requested all the field units of DOT, the LSA units, to organize such awareness sessions at their levels, taking a lead from the leaf out of the webinar or the workshop that is being organized by NTIPRIT. So we have requested all the DGT field units to organize such workshops at their level in the states to create awareness about the need and the benefits arising out of IPv6 transition. So this is the IPv6 status country-wise. So as you can see, India, both in terms of the absolute numbers as well as in percentage terms, it is leading the pack. But if we go service provider wise, then we can see only the 4 top service providers, Reliance Jio, Bharti, Vodafone and Idea Cellular. They are in the top bracket, whereas it is in low single digits for most of the other operators. So there is the need to recognize that IPv6 is a much more secure addressing system, and all the ISPs, all the TSPs for their internet addresses should progressively move towards IPv6 at the earliest possible. And through this session, I'm looking forward, not me only, my entire NT team will be glued to this session, and we will like to learn from the participants or the eminent speakers to follow and the question answers to exactly know where we are lacking and how we can expedite the IPv6 transition. So we are ourselves focused to learn from this particular workshop as to where we can make amends and where are the low-hanging fruits which can be easily plugged to improve our position further, to consolidate our position even further. So we request the TSPs and the ISPs who have already implemented IPv6 in their networks. So all the 4 top cellular operators, they should share their experience through organizing sessions in coordination with DOT field units and guide other service providers for its faster adoption. Then IPv6, as I already mentioned, it is much cheaper and available in plenty, should be the driving factor for its adoption. The thrust on internet needs to be maintained for continuous usage and further adoption by masses, and the use of IPv6 shall allow for usage of stronger security to be designed futures of IPv6. So as DG sir mentioned, as we embark on the 5G journey, it becomes all the more important that our transition to IPv6 gathers pace and we are able to complete the IPv6 transition at the earliest possible. So industry and the government should work in a holistic way to improve IPv6 migration for all the for benefit of all the stakeholders. So with this, I conclude, and I once again thank all the organizers to have given me this opportunity to share my thoughts and more importantly, to listen to the views of eminent speakers and to create awareness to the various stakeholders. Thank you very much.
Thank you, sir, for a very informative session covering IPv6 roadmap in the country, various timelines, progress made, and way forward in this regard. Now we move to our second session on IPv6 awareness by Shri Praveen Mishra, who is Additional Director and Scientist E at ARNet India. Shri Praveen Mishra is a graduate in Electronics and Communication Engineering and a postgraduate in management as well as computer application. He is having more than 25 years of experience in new technology integration and infra management, technology induction, e-infra, strategic alliance, requirement analysis in the area of internet technology. He has successfully delivered projects at national and international level at government as well as corporate world. He is ISO 27001 qualified lead auditor and disaster recovery and security specialist. He is also a certified security specialist and ethical hacker. Apart from handling live IPv6 infra in his current profile, he has to his credit of having provided hands-on training to more than 600 employees of different government department PSU. Over to you, sir.
Good morning, everyone, and good morning, distinguished members present here. The topic that has been given to me is IPv6 awareness, and many of the things that people have already talked about. So I would like to take you, just give me a moment. Is my screen visible?
Yes, sir. Yes, sir.
Okay. So We have been talking about IPv6 for almost more than a decade now, and there has been a lot of progress that has been made over the years. But as my predecessors also pointed out, that it is still a long way to go. So this awareness session that I am going to be taking would be more to sensitize people the need for moving on to IPv6, beginning with the history of TCP/IP. The version 1, which came in 1973, was only meant to cater to a few PCs. So that is how this TCP was developed, to just meet the requirement of connecting a few PCs. And initially about 3 PCs were only connected to the first communication that happened. Over the period of time, different versions came out to meet the need of the devices or the network as they started connecting. And so IPv4 that we see today was born in 1981 to connect some networks of different regions. And that is how Internet was born. IPv4 itself has transformed or has been amended with A and B, although we call it IPv4, but there has been significant changes, or you can say amendments to the protocol itself to make it more stable and cater to the features that come up.
Sorry, sir, to interrupt. Sir, kindly make it full screen and presentation.
I have made it full screen. Is it not full screen?
Yeah, not coming, sir.
Just a minute, I will do it again, please.
Share again and share entire screen.
Now it's okay. Yes,
okay.
Sir.
Is it full screen now?
Yes, sir. It's okay now.
So sorry for that. It was showing full screen on my desktop, but I suppose again it was some technical issue. Anyhow, so the IPv4 that we see today has been there from 1981, and so IPv5 that came as a subsequent to IPv4 was an attempt to transmit voice over packet switching networks, which was an experimental testbed, and it remained as a experimental testbed. And we moved on to IPv6 when we found that IPv4 has its limitations in catering to the requirements that the internet has posed now. As we can see, internet had its organic growth over the period of time. So obviously, when the networks were small and the number of devices that were less, the amount of resources, if you say from IP numbers or from security perspectives or from any other feature, had been bare minimum. But as the internet grew and the number of devices and the topology, everything started having its own wider implications. There were actors also in different parts of the world who were good and bad both. So we had security concerns also popping up. And obviously with the number of devices that started growing, the challenges to the numbers that were available in IPv4 also got to a level where we had issues with its exhaustion. So if you see in 2022, we are at a level where IPv4 with all its numbers of 4.2 billion would not be able to support. Obviously, we are supporting these many devices for the reason that people found different ways of reusing the IP, like DHCP or for NATing. And so we have been able to sustain the networks and the growth of the networks over a period of time. However, this sustenance with mechanisms such as NAT and DHCP have their own implications both on security as well as on the efficiency of the networks that we see today. IPv4, we all know, has exhausted. So we need to be moving on to IPv6. That's something that most of my other speakers have also raised this concern. What is the difference between IPv4 and IPv6? So obviously it was deployed in 1981 and the new protocol has come in 1999. Address size 32-bit is for IPv4 and now we have a 128-bit number. So that is something which itself gives us a huge amount of address space for us, for the internet to expand and for the networks to expand and explore new devices to hook onto it. The address format, IPv4 had a decimal notation where we had dots into it, whereas in IPv6 is a hexadecimal notation with a colon into it. So that's a format change that is there. So one is that it has moved from a decimal to a hexadecimal notation. So instead of using 0 to 9, we are able to use 0 to F into it. So that's one part. The other one is that the format has changed for from dot to the colon. So we have 4 sections in an IPv4. In an IPv6, we have 8 sections present out there. Again, prefix notation, I think this has already changed way back when we moved on from in IPv4 to CIDR using the slash notation. So there isn't much difference that has come. Obviously, as per the routing policy, you need to be having a /48 routing to be done, the bare minimum routing that can be done on an ISP network. In IPv4, a /24 or a class C could have been routed. So that's a difference that is there on the policy front. Technically, even a single IP of V4 or V6 can be routed, but that's something to keep the routing tables within a specified length. Number of addresses, obviously, we have about 4.2 billion addresses in an IPv4, and IPv6 has enormous number of addresses with about 3.2 trillion addresses. Now, coming to the difference between the two, IPv4 as such was made for connecting less number of devices, and initially it was designed for captive networks or networks that were within a certain known area. As internet took off and an organic growth happened, the network of networks that came up as an internet had devices connected globally from different parts of the world in a very complex manner. Now this made many of those, the IPv4 protocol itself was changed to accommodate many of the challenges that were there. And that overloaded the headers to the level that the protocol itself has become inefficient to some extent and insecure, obviously. So we have been using a lot of feature, I would say softwares over it, like IPsec. We use it as a client-server mechanism or a client-to-client mechanism. Same is the case with your VPNs. We use a client-server mechanisms. So these were some of the things. Even on what you call fragmentation. The IPv4 fragmentation was an inbuilt feature which could have been, which was being exploited for snooping and all that. In IPv6, you have a feature which you can enable for not allowing fragmentation. So that gives it a benefit that there could be no man in the middle snooping that can happen. So the new technology that we have is more efficient, more secure, and has a very large address space, obviously. So coming to the header format, like in IPv4, there was no flexibility since the header itself was made with no feature of having any additional additions to it. So every time that there was any need, the entire header had to be changed. And that is where there was no flexibility. In IPv6, we have a header overhead. We just So in IPv6, we have header which is kept. One is on the efficiency front. The other one is that obviously there is a space that has been given for adding extensions to it. So there's an extension header field out there. Like I said, it has built-in security of IPsec and VPNs, etc. So it's an end-to-end encryption that can take place. You don't need a client and a server mechanism. The entire, if you see an IPsec that we use today in an IPv4, the encryption is at the sender end and at the receiver end. But when the data is flowing in the protocol itself, it is not an encrypted data. So what you are doing is you are saying A will be read as B somewhere else. But when it is going as A, if somebody knows what is there at the other end to be interpreted, he can always get hold of your data. So it's not an end-to-end encryption within the protocol. It is only at the sender end and the receiver end. So that's the difference between the IPsec that we use in an IPv4 address today and what we have in IPv6 inbuilt into it.
Mishra ji, sorry to interrupt you.
Yes.
There is some black box which is a rectangular box, no, which is coming on the say bottom right side of your presentation. So I don't know why it is coming. If you can just say share it again, just close it and share it again.
Let me just do it again, please. I don't think there is. I cannot see on my screen, but still I will do that.
It is not visible on your screen, but we are able to see that.
Okay. Yes,
so as a result, no. If you can just, no, it is still coming. If you can just say share the presentation once again.
Yes, I am doing that. Let me just.
Can see that.
Is it?
Yeah.
Yes.
It is still there. Maybe you can.
I do not know. It is not showing on my screen, so I cannot do anything about it.
Can you, sir, reshare?
Sorry?
Can you, sir, reshare it, the closing and then again sharing?
You can just stop sharing it and then again start sharing.
I did that just now.
You did that.
Sharing your Teams and then sharing again. Teams screen, complete Teams, you can stop sharing once and then share. It will be resolved.
Okay. Just give me a moment.
Yes, sir.
Is it better?
No, sir, it's still coming.
Some technical issue that probably I will not be able to comment on that.
Okay, please go ahead. Is
it to this thing that my
no, it is
cannot be seen?
It is not. It is it's a small box on the right hand side bottom. So it obscures, so say whatever text is coming on the right hand side bottom text or picture, it obscures that. It's okay, like okay. Yeah, now it has gone.
Oh, okay. So
No,
I think
now it has gone. Yeah.
What was happening was that your screen was coming here, so probably that was this thing. Okay.
I see. Okay.
Right.
Now it's fine. Perfect.
Okay,
Yeah.
okay,
Go ahead,
okay.
please. Thank you.
Right. So again, on an IPv6, we have a quality of service that is inbuilt. In IPv4, we used to be having labels that were part of being used in MPLS and other places as quality of service, but that was more of the sender and receiver ends. It was not in the middle path. So whatever we used to be sending in an IPv4 as a quality of service packet was sent from the sender as a priority packet, but it was not that it would remain a priority packet in the intermediary networks. At the end, it would again be a priority packet, but in the intermediary networks, it would be treated as any other packet. So that was something that was there in the quality of services that we had in IPv4. In IPv6, that has been part and parcel of the protocol itself. So what happens is then it becomes an end-to-end quality of service with intermediary protocols, intermediary routers also recognizing it as a quality of service packet and prioritizing the traffic accordingly. So there have been all these significant changes that have happened. If you would say it is that the IPv6 protocol has inbuilt many of the features that were desired and were being used in IPv4, but were being used as a mechanism of client-server basis or source destination basis. So not on a protocol basis. So in IPv6, those things have been inbuilt into the system. Growth of the internet, as we see, has been significant over the period of time. So adoption of IPv6 is happening, and that's a good news. But obviously, the problem is that even the growth that we see has been driven more by the mobile devices. So if you see the significant growth either within the country or globally, they have been all driven by the use of mobile phones. Basically, a large section of the users worldwide use Androids and iOS. So those were already capable of delivering IPv6. With the service providers of the mobile getting enabled on IPv6, those devices have been able to cater IPv6 traffic or work on IPv6 traffic, and so we see this growth happening. But this growth is a happy moment if you see from the mobile device usage, but as the number of devices, if you see that the users use your PCs, your other devices, there are a lot of IoT devices that are coming up and all those things, those still do not have IPv6 enabled in them. They may be capable, but are not enabled. My personal means interaction with many of the campuses within the country have shown that maybe the service provider may have is IPv6 enabled, but the moment he lands onto that campus has only IPv4. So maybe at the edge you have an IPv6, but if the users are not using or are not, the infrastructure is not supporting them to use it, then those users still remain on IPv4, which is an area of great concern and needs to be addressed. Now, we have been talking about the numbers, that obviously IPv4 numbers have exhausted, and so we need to be moving on to IPv6. And that's something that is definitely a driving factor for IPv6 to be to have been developed and means people are implementing. But if IPv6 or IPv4 addresses would have been the only issue, then the easier solution would have been to add a prefix to it. Like we do in our phone numbers, there were phone numbers that were of 6 digits. Then as the number of telephones grew, it became 7. Then the subscribers grew more. We made 8 telephone numbers. So that's something where we have been doing a prefix to the numbers that were there. And the same thing could have been done in IPv4 to get more numbers. But it was realized that numbers is one challenge that is there. There are other challenges that are there in the protocol itself, and therefore a new protocol needs to be developed to cater to other issues of concern that are there apart from the number. And that is why IPv6 is a totally different protocol. So it is, if we are using IPv6, it's something that it is not only the numbers, because numbers, obviously, people are using NAT, people are using DSCP, they are able to cater to, hook on to the internet with those types of applications that are there. Numbers could also have been added with increasing the prefix if that was an issue. But it is a matter of adapting new technology with greater security and features that I think in my previous slide, like I said. So many of those things have been inbuilt into the protocol itself, and it opens a greater area of connectivity and mobile reach. So as the numbers increase, you need to have more things that can be hooked on to the internet in a real-time environment, not behind some netting or something. The Internet Architecture Board, which gives a guidance on how the network devices needs to be made, has made it very clear right way back in 2015 itself that the new devices that should be designed keeping IPv6 only in mind. So that the implication of that is that maybe in future you will not get devices that support v4, or you will get devices that support v4 but with a poorer connectivity and a poorer performance compared to if you have a pure IPv6. So that is something that needs to be kept in mind, that if you keep on using IPv4 over a period of time, you may have challenges to that level. Obviously, develop your skills to meet the next generation cyber challenges and keep yourself hooked onto the internet when everything moves on to IPv6. The world of IPv6 applications, everyone knows that there are a lot of things we are talking about, all types of controls, of environmental controls, kitchen appliances, medical assistance remotely. So everything is coming online. The pandemic itself has brought so many things online that there has been a huge expansion in the number of devices that are hooked onto the internet. And therefore, the need for having a secure, reliable, efficient, and obviously a non-netted network is something where IPv6 plays its own role. We talk about smart, 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 and if you have everything smart, then you need IPs for that. So again, that is where IPv6 comes into play, that if you need to hook on so many billions and billions of devices, you need to be having an IPv6. Now, how can an IPv4 and IPv6 network talk? Now, this is something that is very important. IPv4 and IPv6 are two different protocols altogether. You can say one is English, the other one is Hindi. So if you do not know English, you cannot talk to the other guy who knows English only. And if you know Hindi, you need to be having the other guy also understanding and knowing Hindi to be speaking to you. So these are two different protocols altogether. IPv6 cannot talk to IPv4, neither can IPv4 talk to IPv6. For them to be talking to each other, you will have to be using different mechanisms. But nowadays, dual stack is the best option available, since native IPv6 has reached to the end user environment. And so you need to be using a dual stack for your networks to be able to talk to each other. And that is, dual stack means you know English and Hindi both. So the other end either knows English or Hindi, any one of those languages, then also you would be able to talk to him.
Praveen ji, again, sorry to interrupt you. Again, you know that black rectangular box is appearing on the top of the, presentation. I think there may be some box, you can just close it.
Yes, let me just check. There seems to be one. Okay,
Yeah,
gone?
yeah, now fine, perfect, perfect. Yeah, please go ahead. Yeah.
So challenges on IPv6 deployment. I think the next speakers would already be taking care of that, but I would just like to browse through that topic. Is like I said, they are not backward compatible. IPv6 can only talk to IPv6, IPv4 can only talk to IPv4, and that is something which is a major difference between the two. So a dual stack is the only option that is available, that can be used. Other options that are there of NAT 64 and all makes the network very inefficient and obviously creates more trouble than help out on that thing. Business challenge, obviously, business continuity. So business continuity will remain because if you are using dual stack, your IPv4 is still what was working today would still continue to work. So there is no concern that should be raised that my networks will go down for the reason I'm implementing IPv6. Obviously, if you are implementing IPv6, you need to have a holistic approach. Not that you are doing it on one device and not on the other devices, because it's an end-to-end thing. If there is a breakage anywhere between the source and the destination, IPv6 will not work. It will drop down to, if you have a dual stack mechanism, it will drop down to IPv4. Now that's a good feature of dual stack, that since you have enabled both IPv4 and IPv6, even if your IPv6 end-to-end connectivity doesn't go through, you still can move, your device will automatically move on to connecting through IPv4. So as an end user, if you are browsing a website, you will not find any difference or any disruption that may be coming. Awareness among stakeholders, that's a major challenge, I would say. Procurements, although in a campus network, the procurement challenges are very less. Training needs, obviously, means the training is something that is definitely required. And testing environment requirements, application dependencies. Many of the applications may not support IPv6, and device dependencies. Service-oriented migration approach needs to be there. I'm just browsing this topic because in the next slide you will already know why I'm talking about this. Now this is a dual stack. Like I said, there is no disruption that happens. So I have a PC which is pinging google.com, and so the moment I do google.com, it has both A and AA and quad A, 4A records available. So it first attempt, it tries to ping a V6. Since V6 was available, it went through with a V6. If the V6 is not available, then it will automatically go on to V4. In the other, I think the picture has been a blurred one, so I will just explain. If I need to be pinging a V4, it will still go on a V4 to Google. Or whichever site I want to go through. So dual stack does not create any disruption as such in the network that we are running. So IPv4 will continue to run. Now, big concern has been the cost of IPv6 deployment. So basically, I'm only talking about from the campus perspective or from the user perspective. ISPs and will have their own equipments, and probably many of these things may not be applicable to them with the complexity of networks that they may be having. But devices brought after 2015, the network devices were probably all IPv6 ready. All OS support IPv6 today, including your Windows and everything. Your PCs, operating system starting from XP, although XP used to have a service pack that was supposed to be done to make it IPv6 enabled, but you have all PC OSs that can support IPv6, so there is no cost involved in, or there is no requirement of changing a PC or a server to that extent if I want to enable an IPv6. LAN switches, since they are L2, are all transparent to the protocol, and there is no change that is required in LAN switches for you to be implementing IPv6. WAN switches routers may need upgradation if they are bought after 2015. If they are very old, then obviously you need to be changing them out. Firewall security devices support IPv6, and web-based application. All web servers today support IPv6, And so any website or web application that is running using web servers would definitely be able to support IPv6 just with enablement. You don't need to be changing anything, neither the content nor any of those mechanisms onto the applications itself. Now, basically, the cost comes to sensitization, training, and skilling. So this is what this workshop is also all about, sensitizing people and making them aware about implementing IPv6. Obviously, some obsolete hardware needs to be replaced and some client-server-based applications needs to be revamped. But the major causes of sensitization, training, and skilling, for the reason that I have personally also migrated a lot of organizations onto IPv6 as part of our organizations being implementer and consultant on IPv6 implementation. And in some cases, what we found that the person who was the agency that was looking after or supporting that LAN, since they were not trained for IPv6, over a period of time, whenever there was any difficulty, they kept on removing IPv6. And so at the end of the day, means end of some time, campus that was already IPv6 enabled went back to IPv4 when we visited it another time. So that is something which is people not getting comfortable with IPv6 is something which is also a deterrent, and so sensitization, training, and skilling is something that is one of the major and most important factor that is required to be addressed. This is something I'm just skipping through this for the reason that I think I may also be running out of time. So the number allocation systems and all that we already know. In case anyone needs IPv6, I think NICSI already has NIR IRIN.in, so people can visit there and they can have their own IPv6 from them. Just a small profile of what ARNET does. So what we have been doing is from 2005 onwards, we have been running IPv6 networks. At that time, since there was no service provider within the country that had IPv6 enabled, we were running a leased line of 2 Mbps, which was initially 2 Mbps, then we went up to 2 Gbps onto it. And that is how we started our journey of an IPLC line from Mumbai to Amsterdam, connecting global IPv6 networks and our Indian partners onto it. And some of them prominent Indian users were part and parcel of the IPv6 developments that have taken place globally. These were some of the experimentations that we did on that IPv6 networks that we had. We have a central facility for training and testing. Like I think in my introduction it was said that I have trained about 600 odd government employees across the country on IPv6. So we have created a central facility for training and testing IPv6 products and applications. So what we do is it is more basically focused on networks, not on any other thing. So websites, networks, these is something we have our own setup that we have on which we give training right from your network configuration to your web servers, to your mail servers. So a complete ecosystem of the internet is trained on, hands-on training is given on such an environment. Our website, we have exclusive website for IPv6. Some tools that we use for people to be testing out their configurations if they are reachable on IPv6. And that's the end of my presentation. Thank you very much.
Thank you, sir.
Hope I have been able to keep within the time.
Yeah, sir. Yes. Thank you, sir, for very informative session on IPv6 awareness, particularly highlighting features of IPv6, what IPv6 offers, IPv6 adoption, need for IPv6 migration. Thank you very much, sir. I also request Shri Mishra sir and other eminent speaker to be present in discussion session for answering the various queries of the participant. Now we move to next session, that is third session on IPv deployment issues and challenges by Shri by Sri Anand Raje of Basis Tech. Sri Anand Raje is a technology entrepreneur and researcher currently working in the domain of internet resiliency. He is a community contributor to various internet governance entities and activities. He is a leading Internet Society Kolkata chapter as chair and engaged in various capacity building and awareness programs. Sri Raje has also designed and implemented state-wide e-governance project for land record and registration, commercial tax department in the past. Over to you, Mr. Anand Raje.
Thank you for the introduction, and my screen is visible.
Yes.
Yeah. Thanks for having me in this session. And I was listening to the distinguished guest about the IPv6 adoption awareness and how things are moving forward. And about me, I wear multiple hats. So Business Technologies is an organization who is data and registrar. I am also involved with names and numbers, so both aspects of it. Working with ISPs, we are kind of running a community internet exchange point that's called Kolkata IX, wherein lots of small ISPs are also appearing. And also researching on internet measurement and internet resiliency with support from Government of India, the MITI. So I will be discussing about that also, because that is in line with the IPv6 adoption. So let's start with something where we are measuring the part of it. So the first of all, we see that as previous speakers also highlighted, that India is kind of capable right now and in the world map, and this map has been taken from Apnic Labs. The capability metrics of India is kind of 76.82% in terms of IPv6 capable networks. And the data is taken from last month's measurement. So, but whenever we see a different perspective of it, like Akamai, who is one of the most biggest, one of the CDNs, and I have taken this measurement report from Akamai, the state of internet report. It says kind of 50% traffic, or 50 more than 50% traffic, or 49.1 right now, is coming from Indian AS numbers, or Indian IP addresses. So while 79.8% networks are capable of handling IPv6, but the enabled devices, the users who are actually accessing services, are far less than that. So if we see that both ends, wherein the networks are definitely capable, but the end user devices or end users who are accessing the content over internet are kind of in a very 50% scenario, wherein India is accessing the same thing. The previous speaker Pravinji has shown this Google IPv6 adoption graph. I have taken from the same Google website. Again, it is showing that 40% traffic across all across the world, they are seeing IPv6 traffic, and most of them others are IPv4 traffic. Again, here we see that the content wise, the end user who are accessing content over internet is, and the network deployment and capability of IPv6, there is some gap over there. So, and again, the same thing that that's there. The adoption is the big players. So the previous speaker has also mentioned about this, that Reliance, Bharti, Vodafone, these are the big players who contributed mostly in IPv6 adoption in India. And the rest of the players who are small players, who are actually there to bridge the digital divide, who are there to connect the remote areas of India, who are there to connect those areas which are very essential for kind of bringing the digital services to the Indian masses, are lagging behind in IPv6 adoption. So one of the measurements that I found in on the internet is kind of IPv6 capability in India was 68.70% in 2020. and IPv6 capability in 2021 73.54%. So difference is kind of 4 to 5% movement of IPv6 adoption in India. So maybe the small players right now are the should be in the most focus areas wherein they should adopt IPv6, and then I think the real value of IPv6 adoption will come out. Taking this opportunity, I'm trying to, I'm just giving a more measurement over there. So we are using measurements from APNIC, RIPE-NCC, and other measurement platforms, which is not Indian. So one of the projects that we are driving with the help of Ministry of Information Technology and Electronics and STPI as executing partner, and India Internet Foundation and ISO Kolkata chapter is the implementing partner. We are building a measurement network which is capable of measuring most of the protocol parameters which APNIC or RIPE-NCC is measuring, and it is one of the measurement platform which is kind of measuring protocol parameters which is agnostic. So it is capable of measuring 5G also, and IPv6, IPv4, latency, and other parameters also. One of the core capabilities of this measuring platform is it is having dual stack. It is built in dual stack, completely open source. So any service provider who wished to deploy DNS in their environment, who wanted to understand how dual stack works, any enterprise network who wanted to understand, it is completely open source, so we can deploy anywhere. It is a completely research project. So this particular project right now is highlighting those networks wherein we have deployed these anchors. So orange is IPv4 and the green one is IPv6. So you can see at the end user level, those networks where these anchors has been deployed, most of the anchors are capable of IPv6, but they are not enabled. So they are not communicating on IPv6. So this is one of the challenges that we should address, and going forward, we should understand the challenges and issue, and we try to solve them using different methodology, using different programs and ways. So one of the key aspects, so whenever we have we are working with the ISPs which are very small, like class B ISPs, class C ISPs, who are trying to peer with one of the IXs where I'm technically hand holding them. So there we find that whenever we try to understand their pinpoint, their problem areas, we find that they have very little use of IPv6 at medium and small ISPs. IPv6 preferability is also very less. Operators are slowly also moving to adopt IPv6. Most of our operators are adequately IPv6 compliant in the current scenario. So you have seen that their NOC and their hardwares are capable of IPv6, but they are slowly moving towards that. One of the instances when we have showed that, okay, if you are peering with us, you need to peer with IPv6. So then what happened? Then they have started building their own IPv6 NOC, and then they have started peering. So the first challenge and the first issue from IPv6 from end users is the end user is required to have simplified digital access. So they are not bothered whether it is IPv4 or IPv6. So a big part of end user does not have awareness about IPv6, and that's why there is very less push from users end that I need IPv6 for my purposes. So you need to give me IPv6, not IPv4. So there's very less push and requirement from users. That's one of the challenges. For the new operators, the small operators, the ISPs, so IPv6 deployment is not attractive for them. They see that because the network is running and whenever we will deploy something, so what I will get out of it. So sensitization, what Praveenji was suggesting, is very important at that particular level. So what is for them in the kitty whenever they will be deploying in IPv6? That's one of the major things that we have seen. And because the migration not only it requires cost, but also requires proper knowledge and deployment planning. So that's one of the major areas is whenever a particular small ISP who is catering to the need of a particular region, he is not having that much qualified manpower with them. So maybe they are outsourcing the manpower requirements, even the DNS and the IPv, because the manpower is capable of only IPv4. So again, they don't understand how to plan and how to get the proper knowledge to do that. So these are some of the reasons of slow adoption in small service providers. So we tried to address the common challenges of service providers, and we have seen that the complexity in network topology drawings is one of the biggest challenges for them. When I talked with the ISPs who are peering with us and those who are actually with our capacity building programs, they are telling that Anand, the only challenge we face is the lack of training for our manpower. They know IPv4. IPv4 is very easy to handle. We are using NAT, so there is no issue in that. But again, whenever we are using we are going forward for IPv6, we need to plan the complete network topology, and we need to understand how to plan for dual stack, how to do whatsoever need to be done. And at end of the day, we need to understand that our network will work, because their bread and butter is kind of running the network. Say they don't want to lose their customers because they are trying something new. So for them to make them understand and to have a technological backbone wherein they can directly configure and also connect the users into IPv6 is something which is very important. So capacity building programs at their level, and also working with their, so technical handholding with those guys who are working with them is very important. Network operator groups, NOGs in across the world have been a very big help for them, and the mailing list in NOG is very helpful for them. So if they create a community and the community can share the use cases over there in a particular platform like NOGs, they are really very much benefited. And then these case studies make them very confident that yes, if they have done in my region, then definitely I can do the same thing. Maybe I will take help from them. So these kind of networking events are very important for them to get that confidence in building new things in their network. So this is one of the takeaways from some of the feedbacks that we have taken from ISPs. Again, the NAS devices are still not compatible for IPv6 at hotspot level. So that's one of the feedback that we have gathered from the small service providers. Some user end devices, home Wi-Fi routers, also not compatible for IPv6, which they have deployed earlier. So that's one of the reason they are restricting. So CPs are kind of not compatible. Again, less technical awareness was one of the key factors, which is one of the hindrance. And without proper technical handholding, use of IPv6 on the whole network can lead to security vulnerability. One of the situations over here, even one of the one of the technical guy from service provider was kind of telling me that yes, Anand, what it can, so it can be like the hackers and those who are actually hacking the networks. Maybe I am having very less capability than them. So if I do something on dual stack, tunneling, or any other thing, maybe I will end up configuring those routers in a way which is kind of prone to security attacks. So these are something which is coming out of less knowledge base, less understanding of the production environments, how IPv6 networks run, how IPv6 is more secure than IPv4. What are the new benefits that IPv6 is going forward? But again, these things are there in the minds of service provider network guys who are actually running their own network day to day. So I have talked about ISPs, the service providers, the challenges over there. But again, whenever we are thinking about the IoTs and smart homes, those sensors right now. So if you see the use cases like home automation, surveillance, healthcare, automobile, smart metering, building automation, these are some of the use cases we see. And going ahead, 5G and other facilities, there will be lots of use cases that will come forward, and they need to be on the new IPv6 model. Otherwise, we will not take care of that, because see, one of the smart home will have lots of gadgets. One gateway will interact with that, and then that gateway will be in the ISP system. They need to interact with that. So ISPs need to be, even the service provider need to be sensitized that yes, these use cases, you will not be capable of handling those use cases which are coming in the future. You need to change right now so that you can be adapted to the future. So challenges over here is like the product limitation is there. Lots of products like DVRs, NVRs, cameras are not support only IPv4. They are not supporting IPv6. So they need to change that so that they can support IPv6. Sensors need IPv6 support. These are one of the biggest challenge, that those sensors who are capable of working on IPv6, this should be and firmware dependencies also to be prioritized by from major suppliers. These are some of the challenges which are also creating a hindrance in IPv6 adoption by different stakeholders. Now, challenges in enterprise business. So I also run an enterprise business. So whenever we talk about adopting IPv6 in our environment, or any other player who is trying to, like Flipkart or Amazon, I have seen that Flipkart and Amazon also not available in IPv6. For them, technology is kind of a secondary issue. The first priority is motivation rather than technology, because there are lots of areas of technologies which is not kind of in the research area. They have completely thoroughly implemented, and use cases are there. I'll come into that slides, but we have use cases wherein these use cases can be used by them, the enterprise business providers. So any business, any service provider who is doing e-commerce service or any other services which is not on IPv6, it is lack of motivation rather than technology. So they have unused public IPv4 address, also leading to less motivation. There are lots of unused private public IPv4 addresses within enterprise business providers and other stakeholders. So that is also a lack of motivation. Demand for more IPv6 address is growing. Slow transition, stressing IP to provide IPv4 and delaying transition to IPv6. What happens because of this? These areas wherein a particular business, enterprise business, which is actually catering to the need of customers, are not willing to change into IPv4, IPv6. So the inter-service providers who are actually giving them services are not they are ending up giving them more IPv4 addresses, and they see that because there is no push from user end side and the stakeholder like enterprise business side also. So the motivation keeps rolling away. So whenever there is a motivation for enterprise business to adopt IPv6, again it will give some more input to the service providers that find we need IPv6 from you, and you need to build your backbone into in IPv6. So these are some of the challenges from internet business providers also, which are slowing down the adoption of IPv6. I'll just give you an example of wave content and cloud service over dual stack and IPv6. So if we see, there are less than 20% top web content and cloud services in dual stack or IPv6. And this is kind of very, this is not a good condition. So before this, I was just listening to the fellow speakers, and I was researching on web. And I have just, this particular slide has come across in last 20 minutes. And I've seen that Amazon.in, it's not on IPv6 or dual stack access. Flipkart.in, that's not also there. Twitter.com, that's not also there. PayPal.com, not there. Most of the Indian government websites are IPv6, but whenever I've gone to irctc.co.in, it was my prime surprise that it is also not IPv6 enabled. And that means we need to take care of these aspects also, that those who are actually the top websites and top grossers wherein the client connectivity comes into play, they should also be adopting IPv6 and dual stack in order to make the end-to-end IPv6 connectivity possible. One example from Nixie website. So this is one of the websites wherein there is an IPv6 measurement that is coming up, and I would like to suggest over here to the steam panel that we right now is having capability of measuring these things from the internet measurement platform that we are having. Nixie right now is using this AppNic platform to actually understand this IPv6 enabled websites or not. So herein, out of 20,000 domains, only 1,400 domains are IPv6 enabled and 18,701 domains are IPv6 not enabled. So this is something very alarming. There is need to sensitize and also do some sort of awareness and understanding why this is so. And there are lots of methodologies can be adopted so that this number can grow like anything. So IPv6 is not about internet service providers. It is the whole ecosystem, a whole lot of stakeholders which are actually using the internet resources, IPv6 domains, DNS, and others, and they all need to be kind of in this particular ecosystem so that they can start. And if one stakeholder is starting and venturing into this, all the stakeholders will have that feel that push that yes, we need to get into this bandwagon. So we needed awareness initiatives at grassroots level. That's one of the thing that we should be prepared for. The network operator groups which discuss and help in capacity building is not kind of very active in our country. It need to be very active. ISPI and other players are. Rajesh ji is in this call, so maybe if it could be active in a very local and regional level also. So if we can have regional NOCs and then come back and we have national NOCs, and we can identify the champions who are IPv6 champions, who are DNS champions, who are kind of those who are working on the small network service providers, and if we can bring them in and give them a platform, then automatically their use cases will give a push to the whole small service provider ecosystem and can help the service providers more adoption in IPv6, and having a measurement platform, having other platforms coming up with the help of them will be a really big boost in going ahead for the IPv6 adoption. A forum which continuously monitors the progress and try to bridge the gaps, aid in policy decisions. We should have a forum like that, which is everybody if kind of trying to address some problem issues. Yes, they know that there is a forum which is very active, and they can post their problem statements and they can get automatic immediate resolution of that. So that's also very important. And India-centric IPv6 end-to-end program built for all the stakeholders. These are some of the ideas that has come from the feedback from different stakeholders which we have gathered. I'll just give an example in this talk. Like we have seen that AppNic is kind of very progressive in dealing with the IPv6 deployment, and in their website we see that they are having 10-step plan, transition technologies, success stories, and helpful resources. And they have everything end to end. So anybody who is wishing to use this particular, they want to deploy their network, IPv6 in their network, they have clearly stated plans how you will go for this, the step 1 what you need to do, step 2 what you need to do, and step by step is there. And if you stuck somewhere, they have the requisite course materials and everything over there, and they are coming up with their success stories also. So I have seen there is a success story from Geo also, but I don't see a success story from a small service provider over there. Nixie and other organizations can come up with these type of enablement platforms wherein they can see that yes, my success story is getting noticed. So it will be also a very push factor for others to also come up with, yes, this is something that we have achieved. So technological transformation club with these kind of forums and this kind of capacity building programs will help in lot many ways in more adoption towards IPv6. So some of the feedbacks I'll try to share in this call, in this web conference. So one of the class A ISPs we were talking about is they are IPv6 ready network. They have a technical team, better knowledge and IPv6 configuration. But the problem statement, and they are working with user providers also, and they are starting configuration. So for class A ISP, we have some of the class A ISPs are saying that yes, fine, we are kind of dealing with this and we are into this. Some of the technical awareness of team, one of the class B ISP is taking that technical awareness of the team is required for fully adoption of IPv6. They have lack of IPv6 supported devices like NAS billing software. Lack of demand from end users is one of the concerns area for them. Some of the websites are still not IPv6 enabled. Some end user devices are not IPv6 enabled still now. And these are some of the challenges and issues. And if we go through this, I can see that there is not very unique challenges. They are very generic challenges. The issues are very generic. The challenges are very generic. The solution, we know, don't need to find a unique solution. 70% of the solutions are kind of catering to the need of all the service providers. The only thing is we need good set of motivation, a proper forum wherein we can address these things, good capacity building programs, and technical hand holding to these guys who can actually bring more IPv6 adoption in coming days. So may I have more time, or I can stop? So my submission is complete. So if there is any question, I can take it forward.
Thank you, Mr. Raje. Question will take in the discussion session. So I request, as I already requested, please be present at that time, please.
Thank you.
So thank you. Now we are moving towards last technical session of this workshop, which is on IPv6 implementation industry perspective by Shri B. Nagraj, Executive Vice President in Reliance Jio. Shri B. Nagraj has done BSc, AMIE, Advanced Diploma in Marketing Management, MTech and MA in Philosophy. He is a technology competent and customer focused leader with extensive telecom industry experience in transmission and data networking. Just a moment. Yeah. He is currently working as head of data network planning and engineering division for the rollout of Reliance Jio broadband architecture for mobile, 4G, 5G, FTTX and enterprise. He has been responsible for setting up data network many times while he worked in different organizations like DOT, Reliance Infocom and now in Reliance Jio. He has been responsible in putting India on IPv6 leadership across the globe in the successful deployment of IPv6 across the Jio network. Over to you, sir. तो अपना हटाओ शेयर. That's it.
I'm not able to share my screen. So can you put back my screen that
शेयर कर क्यों नहीं पा रहा? इधर से शेयर कर देते थे. We will share from this side.
Yeah, no problem.
Yes, sir. Go ahead.
So I have to take a real. I'm not able to see your screen. Actually, I'm able to see only your this one, Sandeep.
Not able to see.
I'm actually, I had to go through my presentation, or actually that I'm seeing only your video only on my screen.
We have shared.
Yeah, now it has come. Now it has come.
Now it has come, no?
Yeah.
Okay, sir.
So I actually, this is a real a good opportunity for me. I really thank the organizers for giving me the opportunity. I recall in 2015 when we had not yet launched Geo, and we were actually still in the planning and deployment stage. At the time, there was a workshop by DOT, and I actually worked. I had been a ITS officer of 86 batch, and one of my batchmate, Rakesh Mohan Agarwal, was the host at the time. And we had actually just shared what we are actually trying to do in our network at the time. We are actually, it was still at the planning and design stage. And I'm actually glad that I'm now having successfully deployed and worked on the network for about 5 years. I'm able to present this particular thing back with one of my other batchmates as the host, Srinivas Chaganti. So it's actually, I feel that in this 5 to 6 years, there's a transformation. What we had promised earlier, we are able to deliver. And while actually sharing this particular thing, that actually our experiences, it's actually very extensive, online, on hand, and whatever the challenges we actually did take, we took it on head-on challenges. So there was some challenges which was talked about: complexity, cost, time for migration, motivation. But I would actually say that the passion and willingness to actually pursue against all the problems which comes, that actually is fundamentally required when we are actually doing a technological change. Otherwise, we cannot actually achieve such a gigantic step. I will actually share some of the experiences which actually in Geo which we had done, so which could actually be useful for others. But one of the major things which we did, this one was that actually we had, we actually talked about 1.2 billion population, and actually then IoT and machine-to-machine devices, how much it is going to come. Actually, that with smart cities and smart building, there's actually the opportunities are unlimited and endless. But we cannot do any of these things. For example, in the Corona period, we were able to actually really exist as a country, or rather prospered in this particular time, only because we had a good highway, information highway. So I recall the ministers this one actually that the BJP government actually had told that there will be 3 highways which are required for a nation progress. One is the road highway, second is the water highway, and third is the information highway. And probably information highway is the one actually we achieved with whatever actually this one was there, and that's actually how we were able to sustain even when there was a challenging times like working from home, etc., etc. Whereas I think we have done good progress in the road highways. I will not talk about that. This is not the forum. Water highways is actually another dream which actually I hope it will actually come true. This will actually make India really prosper in the entire this one. Now, coming back to this one, that can we actually go to the next slide? If you see the network as a whole, I will actually limit myself. My friends, co-speakers have spoken about the different technologies, different challenges which are there, etc., etc. I would actually just concentrate upon from the service provider what exactly we actually did and how we could actually really achieve this 97% usage of IPv6 in the network. The entire this one actually I can actually differentiate this plane into 4 areas. One is you can say the UE is actually the data plane, the different users. Here we have got UE6 is a very important thing because that in India we don't have UEs in our control. In all the developed countries, the devices, end devices, they are all actually supplied by the service provider itself. If you go with whatever this T-Mobile, you have to take the T-Mobile device. You have to go to AT&T, you have to take the AT&T device. This is true in almost all the developed countries. Whereas here, customers can actually choose whatever device they want. And when we started the entire journey, the user devices were nearly about 50 to 60% were small end devices, and they were actually not supporting IPv6 or any other NAS, NAT, capabilities in their platform. And we actually really launched the network in a much developed say environment. And if you have to capture and actually become a significant player, you have to actually address all the mass market. So whatever devices which are there, that actually you have to make it enable to actually work on IPv6. So this actually is one of the challenge which we had. So we started with a dual stack. That means actually if the user try to actually register and attach, then actually he'll be given both private v4 and public v6. Why private v4? In India, we actually talked about some major service providers. And actually, if you take all the other service providers put together, my friends from the NIC actually can certify, we have got maximum about 20 million usage with us, about 8 or 8.5 million with Airtel, about 5.4 to 5.5 million from Vodafone Idea. We have got about 4 billion. That's actually what we could actually get being a late entrant, and that either from Apnic or through any other purchases, we could actually garner only 4 million. And any other actually all service providers put together actually that if you take up to 2 million, maximum we got 20 million. So 20 million actually we have to actually serve about 1.2 billion users, only mobile as well as the fixed lines and enterprises, and actually IoT and machine to machine. It's impossible. So you have to actually do private v4. The private v4 is how much is available? Private v4 is actually 10.0/8, about 16 million is available. And actually when we actually fought with the IETF and APNIC and all, so they actually made 100.64/12, which is about 2 million as a private, I mean at least service provider usable this one. And we have got very small in 172 and 192, which actually is less said the better. It can be for a service provider segment. It's actually not going to be very much useful. So if you actually say 16 plus 4, actually we have got about 20 million only private v4. Now we have got about 500 million mobile users. We have got about nearly 5 million FTTH users, 25 million cable users, and actually then other enterprise customers and all. So even for this actually where we are actually a small portion of whatever actually is an addressable market we are covering, that itself is too huge a market where we can serve only with even private v4. So you have to actually make, my friend actually somebody talked about the other say add-ons actually with the help of which actually you can say states and these things and all, some actually that something you can actually make and reuse the private v4 again and again, so that for example every circle sometimes major circles actually about 50-60 million actually are there, even 20 million actually have to reuse about 3 or 4 times. Luckily the network is able to support, and we actually combine with the help of some extensions, we actually do it over here, but very inefficient, because actually it becomes 60 million increases to 80 million and 100 million. I actually add 2 more this one actually in the same circle, then I have to actually once again entire readdressing I have to do. So these actually we have gone through all these things initially as a dual stack mechanism. Now what we are doing now is we are actually going away from this the dual stack, and we are using XCLAT. So this actually this Anand also actually covered about that particular thing. There are 20%. I mean, other than the data plane, there's a control plane, management plane, and application websites and other segment. So this is actually the worst possible IPv6 deployment. Even if you leave out the other thing, is the applications and this websites. There are all the applications like cloud you take. That's all IPv4 dominated. Why? Because actually most of the cloud development actually is happening by Amazon, Google, and Microsoft. They don't have a problem of IPv4. They have got plenty. So so they are actually sitting upon that, and actually that it is easier for them, because most of the things which actually comes here is luckily in the last 10 to 15 years there has been significant improvement in the chipset. The chipset has become very powerful. I don't have any problem actually on the user devices, either for a mobile or for the FTTH customers. More and more powerful devices that come which can support any memory bar CPU requirements. But if you actually go to the clouds and all, they're all very sensitive and very advanced features which are actually being tested. So they are more comfortable to test it on IPv4 instead of IPv6. Only when actually it's completely IPv4 enabled, then only it will go to IP6, until unless you force them. For example, somebody talked about the cloud domain softwares, which are their applications, website. They're all 80% of the websites and applications they are today on only IPv4. They are not even available on IPv6. There are interestingly, like for example, WhatsApp. When we were actually trying to do this one actually, they were actually giving only IPv4. We just tested with IPv6. It actually started working. Then we went back to WhatsApp. Why are you telling actually IPv4 only? You are able to actually give me responses. Actually, the entire thing is working perfectly okay with your v6 servers. You have got your environment enabled with IPv6, which actually WhatsApp was not aware. It's because that any other further development, whatever they have in deployment they had done, it was interesting to see that they were actually already v6 enabled. They were actually not aware. And when we actually showed them that it's working and they acknowledged, and then more and more things actually started coming on v6. But why actually we had to achieve in India this particular thing? When actually that Anand actually mentioned 30%, 40%, 50% type of this one. Why? Because Amazon actually uses only the CDN side which are IPv4 dominated. If I have to take something from Amazon, I have to go back on IPv4. But actually, what we have done actually in our DNS, we actually give we have got actually what are the sites which are available in v4 and v6. We give only quad response as the first preference. We don't even send IPv4 address, so that if the user actually has got IPv6 enablement, which actually we have ensured, and once it is done, actually he'll go only to IPv6 sites. For example, if Google has got both v6 and v4, I will actually send him only to v6 site, not to the v4 site. So this is how actually we actually enable more and more performance. Actually, this one over here. I think you go back to the previous slide only. So there actually, that yeah, please stay here. So this this is the this one that 80% of the websites actually are IPv4, but very interesting, the 20% which are IPv6 and are dual stack enabled, they actually correspond to about 80% to 90% of the internet traffic. And that is why actually we have actually gone to 77%, not because of the websites. I don't know whether these websites actually will migrate or actually give me a dual stack. There are some examples. Actually, I don't want to name this one. Actually, for example, with some of the government sites, banking sites, we actually forced them to make IPv6. But when they did, they actually made up only one small server with small capacity on IPv6. Rest of the thing actually they kept on IPv4 only. So the people actually, my users started complaining. If I go to that particular site, if I use from a geo, the response is very slow or it's not working. Some of the applications are not working. Whereas if in some other actually service provider where they're able to get IPv4 only, they actually is working okay. So I had to go back to those people, work with them, and actually make them to actually understand what exactly is there and make them completely end-to-end IPv6 enabled. I'm giving you these examples because that how much actually this one is there. If I say applications websites is one problem area, second problem area is control plane. Easily the network actually dual stack actually as we go along. Most of the people we have actually deployed MPLS, and the MPLS enables to actually give end-to-end say tunneling capability, so we can actually really do hide the addresses, add the extensions, many things we can do. But still the data transmission within the MPLS network today is still IPv4. That means all the link addressing which actually you do between the links, we have got about nearly 500,000 network elements. And if I have to give IP addresses for each of the links, at least 2 IP address for one end to the other end, I require how much? 1 million actually IP address only for this link engineering. So if I have to actually make even that as IPv6. So for that actually that SRv6 actually is coming, segment routing actually is coming. SRv6 is still actually it's in the testing stages, but actually somewhere in the next year it will get deployed. Then end-to-end actually there will be only IPv6. On the user elements is concerned, we have actually made XCLAT. XCLAT is another translation technology where, for example, if the applications are still IPv4, what we do is, the mobile device or actually any front-end device which we have provided like CPE, we have a CLAT, that is a customer's this address where actually it will convert this private IPv4 or whatever IPv4 address he is using into an IPv6 address. So in my network it comes only as IPv6 end to end. And actually, when actually it's leaving my network, I'll actually do NAT 6.4 and actually send it across the network for a V4. Because I think whatever we try to do, the applications and websites will continue, because until the developed countries realize that everybody has gone to IPv6, they have to do. Unless they get that pressure, the IPv6 v4 is going to continue. This will be there until about 2030. So we may have to live with IPv4, but actually this is like what we usually do. You start a bubble of IPv6, you start a bigger bubble of IPv4, but you go on shrinking IPv4 bubble, you expand IPv6 bubble. That is it. Then actually what actually happens, IPv6 one day will actually swallow IPv4. It will be the bubble of IPv4 will exist within IPv6. Today IPv4 bubble actually has got IPv6. Tomorrow actually, or actually more or less, we have actually done IPv6 is a bigger bubble, IPv4 is a smaller bubble, and then actually probably hopefully in my lifetime I will see that it will be end-to-end only IPv6 that will actually going to come. So next slide, please. You know, the very interestingly actually that Anand mentioned about internet, this one. We are also a service provider, you know, and one of the target actually is that actually we have to make India as #1 in the internet usage. We have got highest internet, this one. We are open internet users, like not like China where things are restricted. But then why we are actually not #1 internet player? It's, if you see, because you know that AS analysis actually of leading people, they don't keep IPv6 at all in their analysis. They keep only IPv4. And if my IPv4 traffic is only 3% or 4%, I never actually go more than to the ranking of 250. So this, if you can see, this entire internet also is there is a lip service for IPv6. But only actually now, actually, as we see this bubble increasing, you know, then actually they will actually also understand more and more on this one. But actually, then people actually ask, why IPv6? Right? What is the motivation? Why actually we are passionate in making this one? It was actually talked about, and this Raju actually had 1 minute. Praveen actually had mentioned about this one in detail. The packets are handled much more efficiently with improved performance, increased security. So only for this, you know, I will actually use IPv6. I'll tell you, I have got how much problem I have got for maintaining this 3-4 million of IP addresses, the IPv4. At least 30 to 40% will remain in blacklisting. And I have to go to the different websites. There are 80, 90 websites. And as a service provider, it's my job to see that my customers get this one. But actually, unfortunately, their devices are actually infected with DDoS, this one, or actually that some other malware, some other antivirus, this one. They're not aware, but they try to actually go into the internet and they do. And actually, they will actually do certain this one actually through their knowingly, unknowingly, they will actually sensitive this one they'll do, and they'll get blacklisted. Who is getting blacklisted? The IP address of the service provider is getting blacklisted. And the customer will complain actually that no, actually I'm not longer getting the service because that site has blocked. Most of the websites take the input from this honeycomb websites, and actually then honeycomb actually has blocked. And actually, to tell you frankly, to actually get the single IP address release, not /24 or this one, a single IP address release, it's a huge effort. And there are no other way, no shortcut methods. So we actually just actually go on blacklisting. We'll actually try to hide for some time. So about 15 days we'll not allocate, and afterwards we will reuse, and so it will come back. Whereas IPv6, I don't have any problem. So actually that, because you know that the devices are secure. When actually they're doing an IPv6 transaction, that awareness and other things are not there. So this actually itself is a huge incentive to actually go for IPv6. So the prefixes of various customers, and this actually I'm able to do it much better, in the sense that actually that I can actually do a prefix of /48, actually even higher prefixes. I have, for example, I allocate for every circle a huge prefix itself, because I have got that much I can actually do with IPv6, which I could not have afforded with IPv6. Only one-time planning, and I actually allocate whatever they require, 100 times more capacity I'll actually allocate. So I do not have to divide circle wise. Whenever they expand, I have to do this one. Nothing is required. And so it makes the routing more efficient. We'll get end-to-end transparency, faster packet processing, reduced latency. This is an interesting case. You know that usually people say that it's a 128 bit, it will take more memory space, so it will actually latency will decrease. latency will increase. No, it's not the case. Like when you're able to do it at transit routers, you are able to handle it faster. You'll get much faster this one. Because the inbuilt IPsec, I explained the malware, virus, intune devices, etc., freedom from blacklisting. This is a huge incentive for actually going for IPv6. Next slide, please. So dual stack is a must because okay, there is, but actually, if I try to make now XLAT implementation, I'm able to actually do about. If you see, we have actually made chipsets, SIM cards, SIMs, and as well as the applications. They were all to be supported with XLAT. So we have actually now 92% we have achieved XLAT capability in the devices. So we are actually doing extensive testing. So now the dual stack I'm reducing to only 8 to 10%. Rest of 90% I'm trying to make it via the XLAT so that end to end, starting from the devices up to my network until it leaves my network. If at all it has to leave for IPv4 destination, it will be still end to end IPv6. So all the OEM implementation issues, actually, interestingly, the OEM actually is one and device is another. For example, if there are same OEM is used, but in different this one, it will actually work in one and it doesn't work in another. So you have to take it up with the vendors and have to get it this one here. Some firmware driven limitation in upgrading IPv4 v6 to the TCP sessions. These are all the things actually we had with OEM and chipset this one. And what actually happened was initially, as I told you, we actually had to deploy with IPv4, the SIM were IPv4. And then actually we made IPv6 SIMs now actually are available. And over the year, we are trying to enable IPv4 SIMs to be actually converted into IPv6 SIMs. But the challenge here is if they're in dormant mode, if they're not being used at that particular time, he has switched off or it's not in the coverage area, we'll miss that particular upgradation over the year. And it's very difficult to actually, we are actually having 500 SIMs. And actually to actually identify the users and actually trying to change 500 million SIMs is not an easy task. So, but actually that we are taking that particular thing about another 6 months, we'll be able to implement entire XLAT. So the transition actually we are doing without impacting customer experience, either roaming and these things and all. We have actually out of the 22 circles, we have identified top 8 or 10 circles where we had this IP address. Rather interestingly, private IPv4 address shortages because I have got 20 million only. How many times actually I have to reuse the IP address? So in some of the circles, 4 or 5 times I have already used. So to change those things actually where the high circles actually usage is there, that actually we are doing without impacting the customer experience. Next slide. I think next one, yeah. So enterprise segment is another thing. Actually, I actually talked about applications. Control is another thing. Actually, we actually talked about 5G. 5G, I'm also an IP address allocator for my own organization. We don't allocate at all. Actually, I'm actually very miser in allocating the IPv4 address. And I challenge and I actually drive everybody to go to IPv6. I only for my POC and this thing, I allocate small IP address, but actually when I go to live, when you go to production, I always say that it should be in IPv6 or at least dual stack. But enterprise segment actually is a different thing. So once again, we are actually a new entrance. We are entering into the market. Enterprise actually are the slowest moving people in this one here, maybe because their applications actually are rather IPv4, just like actually I told in this case. And if they try to do IPv6, they're actually afraid that their IPv4 may this one. And they're actually most of the enterprises, they're actually in the private v4, and they want actually few public IPv4, say starting from 8, 16, 32 maximum to 256. So they say actually that other service provider is giving, why you are not giving me? So there's a continuous demand for IPv4 for the telecom service providers. The enterprise segments is that if you do not do, if you say I'll give only IPv6 unlimited, whatever you want, if they will like to help you, they say actually I will not go to you. I'll go to other service provider who's giving me IPv4. This enterprise segment is one thing which is a big challenge. Web contents is the slowest journey. Applications I'm able to control because that all the leading people on the control plane, they're actually having wherever they're using IPv4. I say actually user plane has to be IPv6. Control plane is actually concerned. I will allow you for about say 6 months to 1 year. I'll allocate only small IP addresses, but within that you have to change. And I have seen that actually they'll always actually make it end-to-end IPv6. But the one actually is the web content is the slowest. We have tried our best. 12 websites in the top 60 actually have migrated in last 18 sites. I'm talking about top 60. Actually, that Anand actually covered many of this systems. They don't have pressure to actually do it because their other this one comes from IPv4, where this challenge is not there. India, China, and actually so Asian countries, we are actually a much different world. Whereas actually those people actually that if you take Europe and America, they have got plenty of IPv4, public IPv4, which they can survive for the next 10 years. So they don't have the urge to actually do it. But if we have to do better, we actually go to IPv6. So enforcing IPv4 trading in marketing leading to increase to inter-service costs. Actually, for example, if you say, still actually, if I had to get some IP address, I had to go to the market. Somebody told $20 per IP address. No, today the IP address actually is available only in a /24 or /20 maximum. The bigger chunks are not available. So I cannot actually do the aggregation is very difficult to do. Even if I want to take it, it is upwards of $50. So it's actually that the cost actually has become prohibitively more. So actually a day will come where actually even if you want to give IPv4 public IP address, will that not be available. So these are the challenges. Next. So solutions and way forward. All 4G, 5G, 6G, with the 4G today, we have achieved this particular thing. In 5G, we have learned a lesson. We'll not actually do dual stack. We'll do only with XLAT implementation. That's actually what we have decided to go on day one with 5G only on XLAT. So end to end, it will be IPv6 only. And all OEMs actually are made mandatory to have this chipset or SIMs which we are actually giving only with XLAT this one configuration. IPv6 configuration only. So this actually all cameras we actually that many other things IoT devices we are actually forcing to go on IPv6. All the connected cars, the environment applications we are actually doing. All health applications we are actually doing on IPv6. DVR actually NVR we had problems. Cameras we had a problem. So we actually started working with the vendors actually to get these things actually done on IPv6. So and we are working with the standardization body for the timing and synchronization for working on IPv6. And we actually would like, just like actually we are actually getting into a service provider segment. I think actually that there are many people like Amazon and the other Google and people. I think actually we should actually give in similar regulatory enforcement actually mandatory for them. Then only actually this can actually accelerate in India. That's actually what we see. Otherwise, it will be this journey will continue. So I hope actually I covered the major challenges which we faced and what actually we worked through to actually make it this one. I hope this story will give enough confidence for everybody that if we have got proper drive, proper this one, actually we can definitely make it happen. Thank you.
Thank you, sir, for very interesting session, sharing the experience of the Reliance Jio. I hope that participant will be benefited by this session. Now we are moving to the last session related to discussions. So I request participant they can ask question by raising their hand or writing in chat box.
Firstly, Sandeep, firstly, yes. I'll request Rajesh Chariaji is there. Okay. He is the president of ISPI. So I request Rajeshji, I mean, what are your, I mean, do you have any suggestions, say, for implementation by DOT? Please go ahead.
Thank you, Srinivasji, and thank you, Sandeep, for giving the opportunity of putting my thought process regarding the IPv6 deployment into our country. In 2010, when we brought this NIR to India, we have come with the target that very soon our users, our service providers will be getting benefited with the IP resources directly allocation from the IRIN. One thing, it's very unfortunate that into our curriculum in academia, in the institute, still we are not teaching the students about the IPv6. There is nothing about the IPv6. Any student coming out from the BBA after doing the BCA, MCA, and they are coming to us for the interview, And when we are asking them, they are just coming with their fixed thought process of DNS, and that DNS and the TCP IP is on IPv4, no IPv6. So that's the major issue what we are facing. We have to approach to the Ministry of Education, Higher Education, to include this into the curriculum so that the student, professor, everybody should know that something IPv6 is available. Number two, basic issue what Mr. Nagaraj was saying about the enterprise. I also want to ask, what about the FTTH? Into the FTTH, the people are still using the IPv4. Reason being that their home devices are IPv4 compatible. They don't know about the IPv6. So this also has a very big challenge. Our IRCTC site is IPv4. Why we are not taking a very firm decision of making payment gateway on the IPv6? Once the payment gateway, railway, bank, and this IRCTC turn over to the IPv6, we will find that around 75 to 80% traffic started moving into the IPv6. So these are the some major issue which we are facing, and that causing that all the service providers are ready with the IPv6, but the demand from the user side is almost nil. Nobody is asking. The network engineer is never insisting or never agreeing for the IPv6. Reason being, IPv6 remembrance is a very tough issue. IPv4 you can remember any sort of remembrance, 101.10.10.1, but IPv6 I have to open my sheet to see what is my IPv6. I cannot remember. So these are some issue, and the basic issue we have to understand, our country is 65% village. The lifetime of our equipment is very large. We are using the equipment till his last breath. Otherwise, we are not leaving that equipment. And when we are using the old equipment and those old equipments are not IPv6 compliance, then you can understand the demand from the user side will come only of the IPv4. One major issue which I also want to point out, government website. Still most of the government websites are on IPv4. Why we are not changing it to the IPv6? When it will be on IPv6 and the demand will come, automatically the people will be getting accessing to the IPv6 site only. So my suggestion will be that we have to have in all line, not only service provider, we also have to see about the user. We also have to see about the education, that how we can put this issue into the education so that student, professor should know that IPv6 is the future. IPv4 has gone and it will never come back. Yeah, a small pool is required by every service provider for making dual stack, but no, IPv6 deployment is easy and best if we are adopting that. And Geo has taken the lead. Geo should also take the lead into the enterprise as well as into the FTTH. Once they will be on the forefront, all the other service providers will follow. Thank you very much.
Thank you, Rajesh ji. Sandeep, now we can open the session for discussion, debate, I mean, whatever we call it. The floor is now open, please.
Participant may ask the question by raising their hand or writing in chat box. So one Mr. Rajesh Parvara has raised hand. So I am just unmuting him. Yeah, Mr. Rajesh Panvara, please.
Good afternoon, everyone. Thanks for giving the opportunity.
Yeah.
Sir, have the officers from Department of Telecommunication and MeitY are present. The onus of implementing the V6 should not be only on the service providers. Why can't we make sure that every equipment which is being imported today or being manufactured in this country must be IPv6 compliant? That is first. Secondly, as our Honorable President Rajesh Chariaji said, why can't we make sure that all the government websites be IPv6 compliant by some deadline. Third, what happens to those customer premises equipment which are not V6 compliant? Because as a service provider, we are ready to take up that challenges, but those customer premise equipment which are owned by customer will always be a challenge. Secondly, if we start from today that no equipment which are being imported or being manufactured in India are V6 compliant. So by say next 1 year or 2 year, every equipment which we have in this country will be IPv6 compliant. And then the third, there are certain challenges by small and medium ISPs for making the IPDR compliance if they implement the IPv6. So for that, I request NPIRT to have a separate session. What are the challenges for small and medium ISPs to implement this V6? There we can elaborate those things and can come out, if some expert can help us coming out with the solution as well.
So, sir, Toshnibal sir, would you like to say something?
Yes, sir. With respect to government websites, I must say that we had mandated in November 2021 in the revised guidelines that all government websites should be IPv6 compliant by 30th of June 2022. And we are in constant dialogue with NIC, and recently we have received the status from them, and they themselves have committed that they are in the process of completing it, but it has got delayed, obviously. So we hope that by 31st of December, government websites will be IPv6 compliant. And with respect to equipment manufactured or imported, should be IPv6 compliant. I must say that government has not taken any decision on this. However, we have already mandated that all wireline connections beyond 31st of December 2022, wireline broadband connections have to be IPv6 compliant. So obviously equipment, whether manufactured in the country or imported, has to be IPv6 compliant. And a few other points I have taken note of, and we will see to it that that these could be of some help in framing our policy going ahead. Thank you.
Sir, only submission is that if the customer premise equipment is owned by the customer, and then the policing should not be the owners of the service provider. There has to be a department who will take care of those things. Because what happens is, if we say to a customer that if your customer premise equipment is not V6 compliant, we'll stop your services, that some other service provider will go and cater to him. So the policing should not be the on the shoulder of service provider. Government himself, government themselves should come out with some policy that from this date onwards, every imported equipment or Indian manufactured equipment will have to be IPv6 compliant.
Thank you very much. We must understand very clearly that there are pros and cons in the process, and we from the government can't be high-handed in forcing everyone to be IPv6 compliant overnight. So it will take its own time, but our only request or only submission is that we should understand the benefits arising out of IPv6 transition and make sincere efforts in this direction without forcing anyone to migrate to IPv6 overnight.
Toshniwal ji, Rajesh Charya this side. आपने तो 31st, you have given a date of 31st December 2022. That after 31st December 2022, every service provider who is providing the wireline connectivity have to be IPv6. If the customer is not ready to take IPv6 and if he is still demanding the IPv4, what we should do?
We can discuss these issues offline. You can share your thoughts with us.
Okay.
We'll include these in our policy going ahead.
As you rightly says that we we cannot force, especially the customer or the user or the public, that you have to buy IPv6 only, you cannot use IPv4. But as we are being forced as a licensee, that you have to compliant and you have to give the services on IPv6. So this is a double-edged sword, how to handle that. Because as Mr. Nagaraj, Jio themselves are saying that if they will not be able to satisfy the customer will go to some other service provider. And in present time,
sir, we very well understand your predicament. And I must say that this is a joint exercise and both of us. So the onus rests not only on the service provider, it also rests with the government. And we mutually have to go together and take forward this journey to IPv6 migration as soon as possible. I don't say these are not strict cutoff dates. These are not band pass filters. So we have to see how fast we can do it. Thank you.
Roshnewalji, payment gateway, railway, airline and bank. These are the 4 sectors. You just convert these 4 sectors to V6. Every citizen will get converted to V6.
So next question is from Mr. Ranveer Singh. Kindly unmute and ask your question.
तोष्णीवाल जी, एक छोटा सा सवाल है. As a nodal ministry for monitoring the implementation of IPv6, we have increased the deadline sometimes 2 or 3 times. Whether is there an analysis that what's the hurdle, what are the reasons for not IPv6 implementation, whether it is capital intensive work or some technology is not available or people are not sincere or they did not felt necessity. What are the basic reasons that we had it could not be implemented and we have to increase the deadline?
Sir, there is a committee, IP Guru committee is there, which is analyzing, and these workshops are also in that direction. We are trying to understand the difficulties, but as I mentioned earlier, the difficulties are with respect to complexity, costs, and time. So, and the consumers are not coming forward. So we have to create an atmosphere where they understand the benefits arising out of IPv6 migration. We know what are the difficulties and we are trying to address those issues. Thank you.
So it is more from the consumer side rather than the service providers.
Yes, it's mutual. Thank you.
Yes. So anybody want to ask question, please raise hand. So now meanwhile we'll go to the chat section. One is asking, sir, please elaborate on the security issues of IPv6. But I think it cannot be told. We cannot tell in few words. So I'll take in the next. Sir, one is asking, are there any impaneled entities with MIT or DOT who can carry out audit of our system for IPv6 compliance? Toshniwal sir or Praveen Mishra sir, can you?
Do you want me to answer?
Yeah.
Okay. I think there was an empanelment done by DOT long back, and I do not know whether that is still valid or not, but there were not much takers for it, so I don't think much activity has gone into it. But there is an empanelment that was done by DOT long back, and that is existing.
Okay, next question, please.
Next question is, sir, from Saikat Hira, if we have IPv6 capable devices across entire campus LAN, then shall we go for dual stack model? If we are using BGP peering with two ISP, at present we have /24 IPv4 address space and /48 IPv6 address space from IRIN. We are announcing entire /24 IPv6 block through both the ISP. Can we do that with /48 IPv6 block?
Yes, of course, they can announce the /48 pool also with their respective ISPs into the BGP, and their traffic will move.
और क्वेश्चन है क्या? Okay. Sir, one is asking how to measure the IPv6 traffic on dual stack. I want to segregate the IPv6 traffic graph from IPv4. Is this possible in dual stack environment? Mr. Baje, can you throw some light?
Yes, it is possible. I think I am answering it. It is possible. Any traffic that you move, since these are two different protocols, IPv4 and IPv6, so it is definitely possible. You have to have some way of doing it, like MRTG or any of those traffic measurement graphs you need to have, and then you would be able to get statistics of your users using IPv4 as well as IPv6 traffic.
One is asking how to create a IPv6 DNS server. There are step-by-step videos that help to do IPv4 but not IPv6. So
there is no difference between the two. I think let me also answer this. There is no difference between the two. If you have a DNS server with IPv6 enabled, I'm saying the server, not your software, any bind or anything that you are using. Your server, if it is on dual stack, you in the DNS, you just need to be enabling the listening. Bind, I can tell you there is a listen this thing. By default, it is given :1. So you just need to put your IP or just put : instead of 1, you can do any and it will start listening on IPv6. For other providers, Windows DNS does it with the GUI system. So it is very much possible. You don't need to create a different DNS server for IPv6.
Sir, okay, thank you. One participant has asked whether it's IPv6 enabled or IPv6 compatible. Distinction, please. Is there any difference, or I think?
See, these are jargons that people play.
Okay.
If it is IPv6 enabled, means you have running live IPv6 onto it. And what was the other word that was used?
Enabled or compatible?
Compatible.
Okay, the compatible is something, again, means it's a question of how do you take it. Compatible is obviously you can put an IPv6 address, or there could be an add-on software, something that you may require for it to be able to use an IPv6. So these are jargons that people play: compliance, compatible, ready. So these it's something that you have to be seeing what do you exactly want. But enable is the right word to use.
Generally, the vendors are saying that it is IPv6 compliant, means the IPv6 compliant, or if the vendor is saying IPv6 ready or IPv6 enabled, means that equipment is enabled with the IPv6.
So one more hand, Mr. DK Shah, please unmute and ask your question.
Sir, is there any government, any?
Not audible. You are not audible. Ani Reno.
ये आवाज नहीं आ रही है.
Not able to hear you. Meanwhile, we are taking.
Or you can type in the chat box.
Hello.
Now.
Yeah,
please go ahead.
Able to answer. Sir, is there any government or any website is there from where can learn the IPv6 addressing and scheme implementation?
Lot of material is available on
YouTube,
internet.
May I pitch in for this?
Yeah.
Yeah, sorry, I was away for some time. There are materials available on net. I have seen that Nixie is also coming up with Training Academy, having some IPv6 videos. AppNic is having very good videos on IPv6 deployment. And one of the questions I was going through is kind of how to implement DNS on IPv6. So I have referred a project that we have done is Advanced Internet Operations Research in India, wherein we have implemented Anycast DNS instances on IPv6 and IPv4 dual stack. And that is completely open source and it can be implemented by any service provider for learning purposes. So if anybody is interested, then we can handhold for that.
Even the ISPI is doing yearly one INOG event in which they are giving the hand-on training to all the people who wants to take the training, and especially we are targeting the educational institutes and students so that they should be able to understand, learn lot of thing into the INOG, and all the international expertise are coming to give the training live. This INOG, next INOG is in Delhi in November. We are very shortly going to announce the date and we will pass on this message through the NTIPRIT.
One more question is coming from CGM CNTX West. Please unmute and ask your question. Maybe, yeah.
I am making him the presenter.
Already made.
I have made him presenter. Rohit Sharma ji.
Namaskar sir, myself speaking from Core Network. Myself Prashant Akikar speaking from Core Network. My query was already answered through my chat message.
Okay.
Regarding the entities. Thank you for that.
Okay, thank you so much.
So I think there are no more hands. Yeah, one question is is it possible for us to shift our servers and router to IPv6 and shift our users gradually?
Yeah, it's possible. It's your willpower.
Okay. I think now most of the query has been answered, addressed. So I think now with this we have come to the end of today's workshop on transition to IPv6 in India. I would like to thank our eminent speaker for engaging us in insightful and informative sessions. Our speakers well articulated the various issues, challenges being faced in transition to IPv6 in the country and ways to overcoming these challenges for faster deployment of IPv6 in the country. I'm sure that the participant would be benefited with these wonderful presentations. I would like to thank DG NTIPRIT Sri Raju Sinha sir for inaugurating the workshop and grace the occasion. I also thank to other officers of NTIPRIT for their support for smooth conduction of the webinar. I also thank Sri Rajesh Charia, President SPI, for his presence. Last but not the least, I thank our participant for joining today's workshop and making this workshop a success. We would like to have your continuous participation in various future initiatives of NTIPRIT as well. Now, with permission from DG sir, we may close the sessions.
Yes, actually in the session there was a special request about organizing workshop for MSME.
Okay, sir.
So I promise that we will take all the inputs from the industry and also find suitable speakers to address, including DOT. So we'll do it sometime recently. Thank you for that. And
very good idea, sir. Very good idea. And really, the NTIPRIT is doing a very great job. And on behalf of ISPI, as Mr. Srinivas was saying, this event should be of ISPI, but there is no difference between ISPI and the NTIPRIT if we are both are joining hands and doing the things for the betterment of the service provider as well as the user. Thank you so much, sir.
Thank you very much.
Thank you all again. Thank you, sir.
Thank you. Thank you, sir. Thank you, everyone.
Thank you,
Thank
sir.
you.